Hello students, welcome to the next lecture on the PYQ questions of CSIR net. Today we will describe the hazard rate and the reliability related questions from the year 2011 to 2023. We will solve each question within the help of the 15-second tricks as usual in my previous videos. Myself Dr. Harish Garg, you can simply follow my YouTube channel, else you can simply scan and join my WhatsApp group for various videos are here. So for example, if you can see on my YouTube channel, there is a playlist of the CSIR net where you can find the previous gate years and the CSIR videos from the last 12 years. You can see also the complete playlist of this. Also a PY questions on the linear algebra, real analysis, complex analysis, Markov chain, all about here. Apart from them, there is one more playlist on the gate statistics where you can find the gate solutions of these all previous year papers. So let's start with this video. So we will cover all those questions which was asked in the June 2011 to 23 and December 11 to 23 in this CSIR net examination. We will explain all those questions with the help of the shortcut tricks, and we will cover the 30 plus question in the examination. Each year, each examination of the CSIR net, one or two question will definitely ask related to this hazard rate or reliability. The concept is very simple. So let's say this is a unique approach which is only available at my YouTube channel. So I will firstly recall that what is the reliability, what is the formula for that, and how you can approach them. There are the several notation I have used. Capital T is my lifetime. Wherever F is denoted, this is a PDF, probability density function, or some probability density function. Capital F is called as a CDF. R is called as the reliability or the survival function. Lambda or H is called as the hazard function. Only the lambda, that's a constant, is a failure rate or hazard rate. MTTF is a failure, mean time failure, and the mean residual lifetime. In each of the question which was asked in this examination, they are related to these topics. How you define the reliability? It is nothing but the probability of their survival. And you all know how you can find the probability. It is from the integration of this one. Moreover, you can write this expression in the terms of the CDF as well. So I can return this number as here. Once you can find this, then what is the expression for the mean time between the failure or mean time to the failure? As you know how you can find the expected values in the probability. This is x into probability density function. The same for here. Here is a random variable is a t. So we can say t into f of t. Remember the relation between the f of t and the reliability is minus derivative of this. This is the simple formula for that. Now there is a relation between the failure rate, hazard rate, and the reliability. So what is the f? As I told you, f is nothing but minus dr by dt, and here. So remember these three formulae I have used frequently to explain these examples. There are the two categories of the reliability. The first one is the series system. The meaning of that, each of the component must work so that the system will work. So you can say if this is my first component, say A1, this is the A2 and AN. So that is the reliability of this. That is the intersection of this. How you can find the intersection probability? If they are independent, then you can find that A1 into A2 up to A of N. So then if I call as this is the reliability R1, this is the reliability R2, this is the reliability Rn. So that means this is nothing but my product of this reliability. And how you can find the mean time between the failure? We can find the failure rate, then it's a reciprocal of this. And because each of the number is a probability, so each of Ri is lies between 0 and 1. So we can say it must be less than or equal to minimum of each Ri. That's also one of the most important concept. Now once they are the reliability in the series system, then you can find the reliability failure rate of this is lambda 1 plus lambda 2 up to lambda, and this is the failure rate of this, failure rate of this, and so on. Once you can find the failure rate, you can take the reciprocal, it's a mean time to failure. Another concept is conceived of the parallel system. What is the meaning of the parallel? Each component must work, what is that? At least one component work so that system will work. So it means either the first component will work, either the second component will work, or the third component, and so on. So then how you can find this one? This is nothing but A1 union A2 up to AN. So how you can find that? 1 minus probability of neither of them work. That's the way, neither of them work. So what is the probability of the neither of them work? So you can simply say this is 1 minus R1, R is a reliability, and so on. Or you can say this is nothing but 1 minus product of a reliability. Again, how you can find the MTBF? This is nothing but the reciprocal of here. Fine. How you can find that if this has the component lambda 1 and so on? So first case is if I assume it has the same value, that is the IID, then you can define the failure rate by using this shortcut trick. Fine. Remember, this is a very useful shortcut trick to solve the problem. This is applicable only when each components are my IID. Then you can find this value as 1 over lambda p. What will happen if each components are not IID? Then you can find this shortcut tricks 1 over sum of them, lambda 1, lambda 2 and lambda n, minus their 2 combinations are there, plus there are the 3 combination and up to so. Now you have the 2 systems, series and parallel. Make sure the reliability of the series system is always less than of the parallel system, and the failure rate of the parallel system is always less than of the failure system of the series system. So these are the 2 beautiful tips for you. So let's start with these questions. So how you can think about the question? Before that, you have to just think about this is the f. F is my probability density function. So remember, this is because your target is to find the failure rate. So you always use this formula when the failure rate is given to you. So it means this function is given to you as of this nature. Fine. And remember, exponential reliability part is always in the form of the exponential. So it means this part is my reliability. Fine. And it means this part is nothing but my failure rate. Fine. This is the simple concept, you can remember it. Now what is the question said? They are increasing, decreasing or rate. What is the formula for the increasing, decreasing? You can find the derivative. This will be my derivative. Fine. Now you can check whether it's a greater than 0 or less than 0. Let's say for the first part, it's an increasing function for all alpha greater than 0. That is not true, because if you take alpha is lies between 0 and 1, what is the meaning of that? Lambda dash is less than 0. That means it's a decreasing function. So the first option is cancelled out. It is a decreasing function for all alpha greater than 0. Is it true? Is this value always less than 0? No, because if you take alpha is my greater than 1, what is the meaning of that? It is greater than 0. That means increasing. So this option is also cancelled out. Look at the third option, is an increasing function for some alpha. That's true. If I take alpha is greater than 0, greater than 1, then it is always greater than 0. So it means it's for some. Fine, because alpha is greater than 0 already given. So this is the right answer. Is a decreasing function for some alpha. That's true. If you consider alpha is between 0 and 1, it's a decreasing function. So the right answer is my C and D. You can see how many seconds you needed to complete this one. So look at this. With the same technique, we can move on the another example. Again, I can use this approach, F over R. Okay, this is the exponential part. So this is my reliability and this is my failure rate. So this is my lambda is alpha times x minus mu of here. Then the hazard function. So that means you have to find this part. So you can take the derivative alpha minus 1, x minus mu, alpha minus 2. This lambda is called as the failure or hazard function. This is the hazard function. Now you have to check, is a constant for all alpha. Is it constant for alpha? No. Why? Because if alpha I consider as say 3, fine, so then it is not a constant, it dependent upon the x. So it means the first option is cancelled. It is an increasing function for some alpha. So when is it greater than 0? It is greater than 0 if and only if when alpha is greater than 1. And since alpha is greater than 0 and it is here, so it means yes, it is an increasing function for some alpha. It is independent of alpha? No. Why? Because you can see it is independent of alpha only. So it is not independent of alpha because it dependent upon the alpha. Cancel out. It is independent of mu when alpha is 1. So what will happen if alpha is equal to 1? Then your lambda of t will be alpha only. Now you can see it is independent of mu. So the right answer is my B and D. So always just think about this simple rule and then you can solve this as simply way. Look at the another one. X is my lifetime. The cumulative distribution function, the CDF, is given to you, and which of the following is true for the hazard rate. So it means you firstly find the value of this. Can you find the value of this from the CDF? That's a simple derivative. Fine, we all know this is the CDF, this is the PDF. Fine, this is my PDF, this is my CDF. So what is that? This function is, if you take that derivative, it will be, it's a 0. This will be my gamma t raised to power gamma minus 1 e raised to power of this. Fine. So clearly says this is my reliability, this is my failure rate. So I can consider the failure or hazard rate is my here. Then again they are talking about the increasing and decreasing, so you can take that derivative. So this is my here. Now you can check your answer. Is it increasing when gamma is greater than 1? So when gamma is greater than 1, what is the meaning of that? Lambda dash is greater than 0. So it means yes, it's a correct option. Is it decreasing when gamma is greater than 1? That's the wrong option because it's always greater than 0. Is a constant if gamma is equal to 1. So if gamma is equal to 1, what is the value of the lambda dash? So lambda dash is 0. What is the meaning of that? If derivative is 0, it means this is my constant. So that is also correct. Okay. Or you can also say if gamma is equal to 0, 1, you can substitute here what is my lambda of t. So it is nothing but my 1, which is again a constant number. Lambda is a decreasing function when it lies between 0 and 1. So whenever gamma is lies between 0 and 1, what is the meaning of that? Lambda dash of t is always less than 0. So what is the meaning of that? Is a decreasing function. So the right answers are A, C and D are my correct answer of this problem. Okay, look at this another one. The hazard rate of the time variable with respect to the CDF and the PDFs are here. So H1 is given to you here, H2 is given to you here. Fine. Then you have to find the CDF. Now in this case again we are using this formula. Fine, we need a F, we need a N here. Firstly we can find the value of the R. What is the formula for the reliabilities? E raised to power minus of H dt. Fine. So now based on this I can find the value of the R1. So what is that? If you integrate them, it is e raised to power minus t cube. What is the R2? Reliability corresponding to this, e raised to power minus t4. Fine. Then how you define the failure rate? So you can see this is either 1 minus R, or you can say F is a failure rate, it is nothing but the derivative of this one. So since we don't know about the F, otherwise you can find the value of the F from here. What is the F1? Is 3 t square e raised to power minus of this, and F2 is 4 t cube e raised to power minus here. Now look at the options. So whenever t is greater than 0, F1 is greater than F2. So I can start from here. Fine. So look at that. T cube is always be greater than of this when only when t is my less than of the 1, or t raised to power 4 is greater than of t raised to power cube whenever t is my greater than 1. You can say t is equal to 2 for example, then it's a 16 is greater than of this. Then minus of t raised to power 4 is less than of minus of this. What is the meaning of that? E raised to power t raised to power 4 is less than of this. What is that? This is my R2 is less than of R1. So 1 minus R2 is greater than of 1 minus R1. So 1 minus R2 is F2 is my greater than F1 when t is my greater than 1. So this option is correct. While for this case when t is lies between 0 and 1, and clearly says this result is not hold because it's a greater than 1. So if I consider t is equal to 2, it means this relation hold. This is cancel out. Similarly, we all know how you can define the F1. F1 is lambda 1 R1, F2 is lambda 2 R2. Fine. and we see R2 is my less than of R1. Fine, R2 is less than of the R1, and what is that? If R2 is less than of R1 when T is my greater than 1, and when T is my greater than 1, what is the relation between H1 and H2? So definitely H2 is my greater than of H1, but if you product them, it will not find a relation between them. How you find the expected value? Again, that's very simple. So I can rub this side. How you can find the expected value? So expected value of E1, which is nothing but my reliability from 0 to infinity. So what is that? This is my here. Fine. So what is this 0 to infinity of this? So if I consider T cube is say Y, so what is that? This is 0 to infinity 1 over 3 e raised to power minus y raised to power minus 2 over 3. Fine. So what is that? E raised to power 1 is nothing but gamma function of 1 over 3. Similarly, if you find the E2 is nothing but my here, so it will be my 1 over 4 gamma function of 1 by 4. Fine. Now we all knows gamma function is an increasing function, so therefore gamma function of 1 by 3 is greater than of the gamma function of 1 by 4. Gamma value of the 1 by 3 is greater than of the gamma of 1 by 4, and 1 over 3 is also greater than of the 1 by 4. So if you multiply them, it will be see E1 is greater than of E2, but he said E1 is less than of E2. So the right answer of this problem is only B is the right answer. Just try to think only about this concept whenever they are talking about the probability density function. Okay, look at this one. Again the F is given to you, but here you can see it's my plus sign, so you can't say that the you can't find the value of the H directly from this. Fine. So then how you can do that? Look at the option. So how you can find is H is F over R. Fine. So firstly you can find the value of R. So what is the R? Is integration of t to infinity f of x dx. Fine. So once you integrate this of from 0 to infinity, it will give you e raised to power this minus minus plus 2 of 4. It will be my 4 times, sorry, it's my 2 of this e raised to power minus 2. This is my R. Now look at the first option. When p is equal to 0, fine, and p is equal to 1, I need to find the h. That means our target is to find the h. So what is the value of the f when p is equal to 0? P is equal to 0, its value will be my 2 e raised to power minus of 2x. Fine. And if you think about that, if p is equal to 0, what is that? This is my h of t, which is a constant. Otherwise you can substitute here. This is my 2 e raised to power minus 2x. When p is equal to 0, this value will be my e raised to power minus 2x. Again it is my constant. Similarly, when p is equal to 1, what is the value of this? Is p is 1, so p is equal to 1 e raised to power minus of x. Again you can see what is the value of the h of t. The coefficient is my 1, so again this is my constant. Fine. So it means the first option is my correct option. It's a constant value for all the p. So you can see how you can find that. I can substitute the value of the h. F is my given, so it's a p e raised to power minus x plus 2 times 1 minus p e raised to power minus divided by of this p e raised to power minus x plus 1 minus p e raised to power minus 2x. So can I write this part as 1 plus p e raised to power minus x, and of this I can break this into the 2 part, so it will be my here. Fine. Now you have to prove it's a constant for, so you can take any value, say p is equal to half. So what is this expression? It is 1, it is a half and half will be cancelled out, so you can see it is not a constant. Why? Because it depended upon the value of the x, so it means this is not constant for all the p in between 0. It is a decreasing function, it's a non-monotonic. So look at that, this is my h. If I take that derivative, so 1 will be 0. So p I can for all p. So if I take p as my half, this is my expression. Fine. And clearly says e raised to power minus of 2x divided by this is my decreasing sequence. Fine, this is always be less than of the 1. So it means this is my here, so this is the result hold. Otherwise you can find the derivative of this, it will be less than of 0 for all the p. Because it's a decreasing sequence, so it can never be non-monotonic. Non-monotonic means it neither be increasing nor be decreasing. So the right answer is my A and C. Okay, look at this another one. Consider a parallel system with the two components. So these are my two components which are the parallel. The lifetimes are my IAD and each having the exponential distributions. So if I say xi follows my exponential distribution with here, then the expected life. So what is the shortcut tricks for you? What I told you, how you can find this is 1 over lambda of 1 over I. I very strong, there are the two components 1 and 2. What is the lambda is? The mean is my this. So it is my of this. Fine. So what is that? It's 1 plus 1 over 2. So right answer is 3 over 2. So you can see there is no need to do any of the integration. Just look about this shortcut tricks. So since mean is 1 exponential, what is the mean of the exponential distribution here? So lambda is my 1. So you can see the lambda is my 1. Okay, look at this another one. A parallel system has n identical components. So there are the, now this time it has my n components which are my identical. Fine, identical, and each has the components. So it means lambda is my 1. Fine. If the lifetime is my denoted by this, which of the following statement are my correct statement? So what you can do, that's a very simple. You can see xi follows my exponential distribution with the parameter 1. Fine. Now they are my parallel component. So what is the meaning of that? If I take all, must be at least one of them will be working. So what is that? It follows my gamma distribution of this. Clear? There is no issue about that. Then you can think about that. If I say y follows my gamma distribution of alpha comma beta, then what is my mean of the y? Mean of the y is here. What is the mode of the y? Mode of the y is alpha minus 1 over beta. What is the median of the y? Median of the y is not given in the closed form. Fine. Now based on this simple concept we can get the answer. So look at that. First value, mode of the x. So what is the mode of the x size? You can see I can return this number as exponential distribution. I can also return this number as gamma of 1 comma 1. Fine. So what is the mode of the x? It is nothing but 1 minus 1 over 1. It is a 0 for some m, because if I simply take n is equal to 1, what do you mean happen? It means x1, this expression becomes my gamma of 1 comma 1. Otherwise it will be 1 minus 1 over n. So the first part is correct. The mode of the x is always less than or equal to 0 for all n. You can simply take n is my 2. It means it has a 2 component. Then your target is to prove mode will be less than of 0 for all n. So clearly says the mode will be alpha minus 1 over beta. If I take n is equal to 2, the mode is always be a 0. So it is always less than or equal to 0. It's also correct. Mean is always be greater than or equal to 1. So what is the mean is alpha over beta. So what is that? What is the mean is 1 over n. So whenever whatever the value of this, the mean is always be greater than, yes. So okay, fine. How you can find the mean? I can use this again rule. If I take n is equal to 2, for example, 1 to 2. So what is that? 1 over. It is 1 over 2. It will be my 3 over 2. So 3 over 2 is my greater than of 1. Fine. So mean is always greater than of 1. Since mean is not given in the closed form, so it can be any of thing. It can be greater than of 100 for some n, that's true. If it is given that for all n, then it is not true. So that's a simple way you can see the right answers are all are my correct answers. You may think about like of this way, then you have to think about the reliability of the parallel component. But from here you can find the mean is 1 over 1. Otherwise Otherwise what you can do is, you can see because they are the parallel component, so what is the mean of the parallel component? So the mean of the parallel component will be my 1 over lambda summation of 1 over I varies from 1 to n. So if I take n is equal to 2, then it's a 1 plus 1 over 2. So definitely 1 plus 1 over 2 must be greater than of the 1. Okay, system has a 3 component, and the system work if at least 2 of the component work. At least, that means you have put the conditions on this, at least 2. Fine. The lifetime of the components are IID, and exponential distribution with the mean is 1. Fine. Then the expected value, again I can use the same shortcut tricks for you. This is 1 over I. Now in this case the minimum value is my 2, and what is the maximum unit is 3. So now you can solve that. So it's a 1 over 2 plus 1 over 3. So the right answer is 5 over 6. You can see within a fraction of second you can get your answers in a right manner. I hope you can put a like on this my videos and comments on that. You can also share with your friends. Suppose the system 1 has the 2 component. So this is my system 1. It has the 2 component, and C1 and C2 are my series. There is a system 2 in which the 2 components are in my parallel. Fine. Each components are IID and the mean is 1. So it means Xi's or the Ci's is followed by exponential distribution with the mean 1. Fine. If Si and Hi's are my hazard rates and the here. So look at that. This is my series. This is my parallel. Fine. So what I give you already tips that the reliability of the parallel is always be greater than of the reliability of the series, and the failure rate of the parallel is always be less than of the failure rate of the series. Now you can see about the tips. What is the survival? What is that? 2 is my S1 and S2. So 2 is my second component. Second component is my in the parallel. So S2 must be greater than of the S1. Lambda 2 must be less than of the lambda 1. So you can see the option. This is the correct option. This is the wrong option. Fine. Now look at the other options. Expected value of the series. So what is the expected value of the series? So as I give you the tips, it will be lambda 1 plus lambda 2. So what is the mean is 1. So it's 1 plus 1, 2. Sorry, it's expected value. It's expected value. Firstly, you can find the lambda of this. It is my lambda 1 plus lambda 2. So 1 plus 1 is my 2. So the mean will be 1 over this. Fine. And if you consider the parallel, then I can take this as the simple rule. So it's a 1. I varies from 1 to 2 because there are the 2 components. So 1 over 2. That means my 3 over 2. So what is the mean is 3 over 2, and it's a 1 over 2. So mean is 1 over 2. Correct statement. Mean of the parallel is 1. It is not a 1. It's but 3 by 2 is the right answer. Look at the another one. Again, x is a positive number with a probability density function. So again, I can use this result. Fine. So this is my reliability. Fine. So the lambda will be my alpha x raised to power alpha minus 1 beta times x raised to power minus 1. So remember, whenever you talk about the reliability, there is also the properties. If somebody asks you what is the reliability of the 0, is always 1. Reliability of the infinity is always 0, and reliability is always with a decreasing function. Fine. Now they are talking about the hazard function, increasing, decreasing, and so on. You can find the value of alpha lambda dash. This is the value of the lambda dash plus beta times of this one. Now look at the option. First option, it's an increasing function for some choices. Can you get some choices so that lambda dash will be greater than 0? Yes, you can do, because if you take alpha is greater than 1, beta is my greater than 1, then this number will always be greater than 0. So it means yes, it's an increasing function for some choices. What are the choices? Alpha is greater than 1, beta is greater than 1. Is there some choices when it's a decreasing? Yes, if you choose alpha is lies between 0 1, beta is lies between 0 and 1. So both the numbers are negative, so the total will also be negative, so then it will be less than 0. So it means this is also there. Can it be a constant? So when it will be the constant, when you prove that lambda dash will be 0. Can it be 0? Yes, if alpha is equal to 1, beta is equal to 1, and both are satisfied here. So it means this is also a constant. So that condition is when alpha is 1, beta is 1. Can it be non-monotonic? That means can it possible that it is neither increasing nor be increasing? Yes, if you take alpha is less than 1 and beta is greater than 1, then this part will be positive but this part will be negative. It means it can never be increase or decrease. Or if you take alpha is greater than 1, beta is lies between 0 and 1, again it shows that it neither be increases nor be decreases. So that means non-monotonic. So it means all the options are my right answer of this problem. So look at this another one. Consider a series system with the two components. So there are the two components which are written in the series and their reliability say R1 and R2. They are only talking about the independent. The component lifespans are here. So it means this follows my exponential distribution with the parameter here. If xi's are here, then the MLE of the reliability. So what is the reliability of the series system? So they are independent. So and you can see each component has a parameter lambda. So it means for the series system you can find this as here. And so it is not in the form of the t, it's form of the x. Then your target is to find the MLE of this. So the only unknown out from the option is lambda. So you can find this value of the lambda. That's very simple. You start from here, find the likelihood estimator of this. How many units you have? 2 units. So I can take this is 1 to 2. Fine, over this xi. So what is that? This is the lambda square e raised to power minus lambda of xi. Then I can, this is my likelihood. So I can take the log of this. So what is that? It's a 2 times log of this minus of here. Fine. Now you can take the derivative with respect to 0. You will get as 2 by this minus of xi is 0. So what is the value of lambda? It is my 2 over summation xi, and we need in terms of the x bar. So what is that? This is nothing but 1 over, what is that? It's the n. How many n are there? My 2. So it's a 2 times x bar. So lambda is nothing but my 1 by x bar. So I can substitute the value of the x here. So what is that? It is nothing but, so here in terms of the t, so you can written this as in terms of the t. So e raised to power 2t divided by x bar is the right answer. So 2t x bar is the right answer. Okay, look at this another one. A system consists of 5 identical units. Fine, no, not independent, identically. 2 parts A and B. So it is consist of the 2 part A, part B, and they are connected in the series. Part A has the 2 units connected in the parallel. This means they are the 2 units connected in the parallel, and part B has the 3 units connected in the parallel. So it means this is my diagram. Fine, this is my system. Then all the 5 units are independent, and the probability of the failure, this is the probability of failure. So firstly you can find the probability of the success. So success is again 1 minus half. So the reliability is my each as a half value. Fine. Then how you can find the probability of this? How you can find the reliability of this? So remember, as I told you, reliability of the parallel is 1 minus product of reliability of this. So this value will be 1 minus half, 1 minus half. Fine. The reliability of this is 1 minus half is half, 1 minus half, 1 minus half. Now both the components are in the series because they are in the series. What is the reliability of the series component? That's the product of the each component. So your answer will be here. So what is that? This is a 3 by 4 into this is a 7 by 8. So right answer is 21 by 32 is the right answer of the problem. Always remember, reliability of the parallel is 1 minus product of the each component, and the series is the product of this each here. The parallel system consists of the n. The lifetimes are independent and identically, which varies over the uniformly distributed. Okay, so xi's are uniformly distributed over the domain A comma B. Given that the mean is here, so what is the mean of the uniform distribution? This is given to be here, fine, and the range is 60. What is the range is? B minus A is my 60. So clearly says, can you find the value of the A plus B from this? So if you solve, clearly says that B will be my 60, A will be my 0. So it means xi's follow the uniform distribution over the domain here. Fine. Now what is given to you? They have the n components which are connected in the parallel. Fine. Now if the expected lifetime is, it means expected lifetime is my 50. So what is the formula for this? 0 to infinity of reliability. Fine. This is given to you as a 50. Then firstly you can find the reliability of this. So if I call this is my R1, this is my Rn. What is the reliability of the parallel is? 1 minus R1, 1 minus R2 and up to 1 minus Rn. Because they are independent and identically, so it means all have the same value. So I can return this number as 1 minus of R of n. Fine. So how you can find the reliability? So we all know reliability is 1 minus failure, 1 minus CDF. This is my CDF. So can you find the CDF of this? Yes, you can easily find the CDF. X minus lower limit and range of this. So CDF is x by 60. Reliability is 1 minus. So what is the 1 minus of minus plus of this? So what is that? It is 1 minus x over 60. So I can substitute this value. So domain is, instead of the 60, infinity is a 60, 1 minus x over 60. Fine. This is given to you. Now you can simplify that. If you integrate them, what will happen is a 60 minus x by 60 of n plus 1 over n plus 1 and divided by 60 of this. Fine. Now I think that is over 60 I can take as a common, and limit is from 0 to 60. Fine. If you take as a 0 to 60, it will be 1 over n plus 1. It is my 5 over 6. So what is that? It is 1 over n plus 1 is 1 over 6. What is the value of the n? N will be my 5 is the right answer. So that's a simple, you have to simplify little bit calculation, but you can do that easily. Okay, the hazard rate, that is H is given to you. Fine. Then you have to find the survival. It means H is given to you, then your target is to find the value of the R. So can you find the relation between this? You can simply check about my shortcut tricks. It is exponential of minus h of x. Fine. Now you can substitute the values. It is e raised to power minus h is my 2x over 1 plus x square. So what is the integration of this? It is my log of 1 plus x square. So what is the answer is 1 over 1 plus x square. So this is the correct option. Survival is my, here is the cancel. Now once you know the R, can you find the value of the F? Yes, you can easily find that F, because lambda is nothing but my F over R. F lambda is nothing but H. So once you know the F lambda, once you know the reliability, you can find the failure rate. The survival rate cannot be determined, but that's a wrong option because we already computed the survival rate. The survival rate density function means that is a F, that is a probability density function, and the distribution function, that is my capital F, R, can be determined from this. Yes, you can already determine. So you can see how many seconds you needed to solve this problem. Fraction of seconds are there. Okay, so there are the three components are connected here. Each have the failure, this. Okay, look at that. Then there is a need of defining the relation. So look at that, the circuit 3, which is my parallel. Fine. Circuit 2 is connected in the series. Fine. What is the circuit 1 is? Circuit 1 is, they are in the series, they are in the parallel. So it is my series parallel. Fine. And what is the tips for you? If I say does not fail. Does not fail means that's a survival. That means the reliability. So if I call this is my R3 system reliability, this is my R2, and this is my R1. So as I told you, reliability of the parallel is always be greater than of the series. So it means reliability of the third, and now they are the series parallel, again it's a parallel. So reliability of the third is greater than of the series parallel is greater than of the series. So that's a simple standard tips for you. Now you can see R3, that means Q3. Q3 is my greater than Q1 is greater than of this. So which relation hold? Correct? Q2 greater than false. Q2 greater than Q3 false. Q1 is Q2 false. So the right answer is only my A. So if you remember these simple tips, series reliability of the parallel is always greater than of the series. Series parallel is always greater than of the series. Second method, if you are instead of this, if you want to calculate them, what is that? Q1. Firstly, I can try to find the Q1. They are in the parallel. So each components are fail with the identically and independent. Fine. So this is the probability of the failure. What is the probability of the survival? 1 minus P, 1 minus P, 1 minus P. Now they are in the parallels. What is the probability of the parallel is 1 minus the reliability of the C, and they are in the series. So it means 1 minus reliability of A, reliability of B. So if I substitute here, what is the reliability of C? 1 minus P. And what is the 1 minus RC is? P. What is that? It's a 1 minus P square. Fine. This is the reliability of Q1. They are in the parallel. They are in the series. Firstly, what is that? This is the R of A into B, and they are in the series of this. What is the R of AB? They are in the parallel. So I can say this is the 1 minus RB, 1 minus R of A. So what is that? This failure probability is my P. So survival is this 1 minus P, 1 minus P. So it is P square, and what is the? This is 1 minus P. What is the Q3? They are all in the parallel. So 1 minus is a product of 1 minus of this. So it is my 1 minus P. Now how you can check that? You can simply take P is equal to half. So then what is my Q3? You can see Q3 is 1 by 8. It's a 7 by 8. Fine. What is my Q2? It's 1 by 4, 1 by 2. It's a 1 over 8. It's a 7 by, sorry, something is wrong. Why? Can you check this calculation? This is my parallel. So I can say this is 1 minus of this. It's a 1 minus product of 1 minus here. So it's a P square. So it's a 1 minus, sorry, it's a 1 minus, is here. Fine. So it is my this one. So 3 by 4, 1 by 4 is a 3 by 8. And what is the Q1? If I substitute here, it's a 1 minus half. It's a half, 1 by 4, 3 by 4. So it's a 3 by 8. It's a 5 over 8. Now you can see what I told you, the shortcut tricks. Q3 is greater than of the Q1 is greater than of Q2, and you can see about it. Again you can see Q3 is greater than Q1. Fine. Q1 and Q2 both are not same. Q2 is not greater than of the Q3. Q3 is. If you want to do some calculation, then you can do. But if you want to do like of simple shortcut tricks, you can do like simple. Okay, look at this another one. Now again they are in the parallel. The failure probability is my P. Remember, this is my failure probability. So what is the survival probability? Is 1 minus P. So it has a 1 minus P. It has 1 minus P. It has 1 minus, and it is a series parallel. So it is 1 minus P probability. Now they are in the series. If you combine them, what is the probability of the series is 1 minus P square. Fine. So what is my F of P? Is the probability of this here. So they are in the parallel. So 1 minus of this P, 1 minus of this, 1 minus of this. Fine. This is the expression of the FP. Now you can check your option. What is the F of half? So 1 minus half. It's a 1 by 4, 3 by 4. Fine. So it's a 3 by 8. So if you subtract 1, it's a 1 5 by 8. So 5 by 8 is correct. It's a cancel. Look at this third option, F of 1 by 3. So what is the 1 by 3? Is 1 over 3. it is 1 minus 1 over 9. It's a 8 over, sorry, it's a 2 over 1 minus p is a 2 over 3. 2 over 3 means 4 over 9. So it is my 5 over 9. So what is that? It's a 5 over 27. 1 minus 5 over 27. It's my 22 divided by 27. It's the correct option. Look at the last option is f1 by 4. So 1 minus 1 by 4. Its value is 3 by 4. So it's a 1 minus 3 by 4. It's a 9 by 16. So it is 1 by 4. It's my 7 by 16. So it's a 64 minus 7 by 64. This is a 57 by 54. But it's a 50 is the wrong answer. So the right answers are A and C are my correct answer. Okay, look at this one. Again, 3 components are in figure. Each are independent and identical. Exponential distribution with the mean here. Fine. So it means it has this one. So if I consider this as R, this has a reliability R, this has a reliability R, because they are identically. They are in the parallel. So I can firstly find this probability and then this has a R. So what is that? It's a parallel. So what is the reliability of this? 1 minus of R, 1 minus of R is here. This has the reliability R, so I can multiply them. So what is that? This is 1 minus R square into R. Now what is the R is? They are the exponential distribution. What is the reliability of the exponential distribution? Minus lambda of t. What is the lambda is? 1. So it means this is 1 minus e raised to power minus t whole square into e raised to power minus t. So e raised to power minus 3 cancel. This is only when all are in the series. This is result when they are connected in this manner. Fine. This is 1 minus of this. It's not cancel. This is option. You can see this is a match them and it is not possible. Fine. So this is the required simplify expression of here. Okay, consider the system with the 2 components whose lifetimes are my IID exponential. Xi's are my exponential with the parameter of this. H1 and H2 are my hazard functions if they are in the series and the parallel. H1 they are in the series component, like they are connected in here, and if they are connected in the parallel, they are the 2 components, then we call as the H2. Then which of the following is there? So what is the tips as I gave you earlier? Reliability of the parallel is always be greater than of the series, and reliability of this parallel, a failure rate of the parallel is always less than of the series. Remember, they are talking about the hazard function. What is the hazard function is? F over R. Fine. Remember, this is F over R. So the first result is fault because parallel is my H2. What is the meaning of that? H2 is less than of the H1. Fine. Now, how you can check about the others are there, whether they are increasing or decreasing. So how you can think about that? That's again a very simple. You can try to write the expression. Firstly I can check for the parallel component. Fine. What is the reliability of the parallel is? Because they are the IID, so they are 1 minus of R whole square. If I open this, it is my 2R minus R square. They are exponential, so what is my RP? It is my 2 e raised to power minus of lambda t minus e of this case. Fine. Then your target is to find the f. How you find the value of the f? It is nothing but my minus dr by dt. So you can take that derivative. It's my 2 of here minus plus of this case. Fine. And since it's a negative sign again, so you can take as negative. So what is my h2? You can simply take the fraction. I can take minus as a common, 2h is outside, e raised to power minus e raised to power of this divided by 2 e raised to power this minus of this. So what is that? You can see I can return this number as 1 minus 2 lambda is outside because they are almost similar, only the 2 difference. So I can return like of this way. So this is 2 e raised to power here, sorry, this is fine, e of this. Fine. Is it true? Now you can see that whether how you can check whether it's a less than of this? That's again simple, because t is my greater than 0, so simply you can take t as infinity. That means you can take the maximum value of the t. Fine. So what is that? It's my 0. Is it 0? Yes, it's no, sorry, it is my 0. Yes, it's a 0, it's a 0, it's a 0 by 0 form. So you have to apply the L'Hopital rule. So it is my 1/2. So that is my, so this is my maximum value. So that means H2 must be less than of this here. So that means this is the whole. What is the lambda 1? Because they are in the series. So what is the reliability of the series? E raised to power 2 of this. So H1 is, so if I rub this screen for you here, what is the reliability of this series? E raised to power 2 H lambda of t. Now you can see what is that, this value will be my, or you can see H will be, if I substitute this value, H will be my here. So clearly says it can never be less than of the lambda, because if you simply take lambda is 1, then H1 will be my 2, but lambda will be my 1, so it is not true. How you can prove that it's increasing or decreasing? Now you can see this is the maximum value. What is the value of the 0? You can see when t is equal to 0, this value will be 0, this value will be maximum, so it is the increasing function. It may be decreasing, but you can see that when t approaches 0, near, then this value will be my 0 by 0. You can apply the L'Hopital rule, it will be less than of lambda. Otherwise what you can do, a simple way is you can take lambda is say 1, t is say 1, for example. Then you can substitute here, then you can use the calculator, you will get. But there is no need, because we already compute the maximum value as my lambda, so it's a increasing function. Okay, which of the following is a hazard function? Fine. So what is the hazard function is? That is nothing but my f of t divided by r of t, which satisfy the following property. That's a very simple. What is the necessary and the sufficient condition for any function h to be the hazard function? Number 1, the integration from 0 to t of h should be infinite. Second part, h of t must be greater than or equal to 0. And third part is h of t is either monotonic increasing or monotonic decreasing or constant. Fine. These are the properties. So look at that. This property hold by using this concept. Fine. H of 0 is 0, is satisfied. Fine, there is no issue. H of 1 is 0, not always true, because it is for all t. Fine. So at initial point is there, that's true. For the initial point is satisfied, but not for the inside. H is a non-decreasing function, yes, because either the monotonic increasing or decreasing, that is also the correct option. So the right answers are A, B and D. And you can see this is a recent year paper. How many seconds you need to solve that? Okay, so suppose h of t is a continuous hazard function. So then which of the following are always true? That means these properties hold. This property hold for this one, 0 to t, h of t of this is my infinite, h of t is my greater than or equal to 0, and it is a monotonic function. Fine. These are the three property already hold. Now look at the options. Look at the first option. It means your target is to prove this result should be infinite, this result should be greater than 0, this is a monotonic function. You can see h is my greater than 1. Fine. Is it true? It is not all, because you can see what is the integration of this? This is always be a divergent. Fine. You can use a p-test even. So it means the limit is not existence. So if limit is not existence, the integration is not a, you can get. So this is not the right answer. Lambda square. Fine. So now clearly says that if h is greater than 0, it is also greater than 0. Integration of h is there, so this is also with the infinite. H is a monotonic or lambda is a monotonic, so this is also the monotonic. So this is a correct option. Look at the C. C times lambda of t, because C is my constant, so I can take C as a outside. So this property hold already, so infinity into c is my infinity, first property hold. If lambda of t is my greater than 0, c is my positive number, so c times lambda is also greater than 0. If it's a monotonic, c is a positive number, so monotonic does not consist, and here. Look at the last, again you have to check about this, and we all know what is the limit. What is that? Is from 0 to infinity. It is not. Is it a convergent? No, it's a divergent, because limit does not exist for that by using the logarithm test or here. So it means this again is not a hazard function. Okay, suppose t follows the exponential distribution with the unit me, then which of the following is a function? Okay, this is a function. How you think about that? It means, okay, you have to think about the function. So it's my unit means, that's a lambda e raised to power of this, so it has a unit mean. Fine, this is given to you. Okay, that's fine. You have to use the transformation because you have to here. So look at that first part. The hazard function of the t is a constant. What is that? Can you find the hazard function of this? It is 1. Why? Because if you compare this by here, the coefficient is my 1. The first part is the correct option. Hazard function of the t square. So you can find the PDF of t square firstly. Very simple. You can take y is equal to t square. Fine. So t will be my root y. So if I consider g as my PDF of the y, it will be function of the t at this point into dt by dy. Fine. So what is that? It is my here. I can substitute the value of t. It is minus of root y into what is the derivative of this? Half y raised to power minus half. Fine. This is the my PDF. So what is that? This is my hazard rate h of t by using of this. Exponential is a reliability, and this is a which is not a constant, because for the different value of the y it has a different function. So this is not a constant. Hazard rate of the t cube. So I can find, say t cube is my y. Fine. So t is my y raised to power 1 over 3. So if I consider the function of the y, I can substitute value of here e raised to power minus y raised to power 1 over 3 into derivative of this. Fine. Hazard function. So this is my hazard function. So h of y is 1 over 3 y of minus 2 by 3. When it will be the identity? This is identity only when the identity, that means if this hold but it is not hold, so this option is also cancelled. Now look at the last option. So if I consider y is my root t, that's a y square is my 2 times of t, then g of y will be, I can substitute this is my y square by 2 into the derivative of t, that's my y of dy or dy square. What is the dt by dy is my here. So what is that? Hazard function is my y, and you can see this is my constant, or this is my identity, and they are talking about the identity. So the right answer is my a and d are the correct option. Okay, look at this another one. You have to find the hazard rate. Again you have to check from f by r. So what is that? This is my r, this is my lambda. So 1 plus alpha x raised to power here. Check whether it's a constant for some alpha. When it will be the constant, when x will be 0, coefficient of this. So if I take alpha is 1, what is my lambda? Lambda will be 1 plus 1, it is my 2, and 2 is my constant number. So it is, yes, it is 2 for some alpha, because alpha is my greater than 0. Is it increasing for some alpha? You can find that derivative. 1 will be 0, alpha minus 1, x of here. So increasing means you have to prove that it will be greater than 0. When it will be greater than 0? When alpha is my greater than 1. So that's true, it's for some alpha, because domain of the alpha is greater than 0. So it's some alpha, correct option. Is it decreasing for some alpha? Yes, again, because it will be less than 0 if and only if alpha is lies between 0 and 1. It's a bathtub. Bathtub means that is either the increasing or decreasing or a constant for some alpha. Yes, that's true, because if you consider alpha is my 1, then it's a constant. If alpha is greater than 1, it's a decreasing. Increasing, it's less than 1, is a here. So this is all are my correct option of this example. Remember, if instead of this, if they are talking about alpha is my greater than 1, then clearly says that this option will be cancelled out. This option is also cancelled out because this will never be decreases. So then only the option is my B is the right answer. So you have to look about the very carefully about the domain. Okay, look at this one. F is my lifetime distribution function, that is a CDF. H is my hazard function, that is my F over R. The mean residual life, M is my mean residual function. F is my absolute end here. Okay, so first option, is it always true? No. As I told you earlier, H is my hazard function. So what is the property of the hazard function? 0 to infinity, hazard function should be infinite, not always 1. So this option is cancelled. Fine. Okay, what is the mean residual life? So as I told you the in the starting CDF definition, this is my f of t of dx. Now you can see. Now because this is integration with respect to x, 1 minus f of t is my constant, which can be taken as the outside, and the numerator part will be 1 minus f of x dx, which is same of this. So this is the right option. Is exponential. So if the lifetime is exponential, m is my exponential function with the mean lambda. Fine, with the mean is lambda, so it's my parameter is here. Then m, what is the m is here. So that is not true. Why? Clearly says that whenever it is my exponential function, so it means the failure rate is my constant, reliability will be my e raised to power minus of lambda t. Fine. If what is that? This numerator part is my reliability. Fine. So if you take integration from 0 to this reliability, what is that? This is the mean. What is the mean of this? It is 1 over lambda, and denominator is again 1, so it is my 1. It's a constant function, but he said it's an increasing function. That is a wrong statement. Look at this one. And once is exponential function, so what is the mean residual life for the exponential function? 1 over lambda. Fine. So now if you substitute here, h is also the lambda. Lambda is my failure rate, that's h. So this is 1 over h. So now from here you can see this result is only constant when it's an exponential. Fine. Okay, look at this another one. Suppose t is my survival rate of the component, having the PDF is this. Capital T is my exponential distribution if and only if. So you know what is the property of the exponential distribution? It follows the memoryless property. Fine. So what is the memoryless property? Probability of t greater than of m plus n greater than of n, nothing but my probability of t greater than of m. Now if you look about that, this result is correct from this side, because if I write this value as t greater than of m plus n divided by probability of this, which is greater than of this number. Now if you multiply them, you can see the second result hold. So second is so. What is the first result? The first result is f of t. What is the definition of the numerator side? This is the reliability. So what is the definition of this? This is my failure rate, and it is exponential. When it will be the exponential? When it will be my constant. What is the meaning of the constant? That means this is my independent of t, and he said that if I say it is independent of t, that means the lambda of t is my constant, and the only distribution where lambda t is constant is called as the exponential distribution. Look at this third option, probability. This is not true, because if you look about this result is only true when they are greater than sign, but they are less than sign, they are not correct. Look at this one, how you write this question. If I say t is less than of this t plus s divided by probability of t greater than t, fine, the left hand side will be my here. So how you can write that? By the definition of the conditional probability. how you write in terms of the conditional probability. So this means T will be less than of the S, condition T will be here. Fine. So what is that? This is also the memoryless property. Fine. So this is also the memoryless property, and if it is a memoryless property, it means this follows the exponential distribution. This is also correct. Remember that whenever this is a less than, then it's a less than, and this conditional must be greater than of 1, but here it is a less than 1. That's why this option is cancelled. Okay, so this all about these PY questions of this 11 to 23. You can simply scan and join my WhatsApp group for the various discussions, and then we can see the next lecture on the Bayes theorem again with the help of this shortcut trick. I hope you can like, share and comment my video. Best of luck students. Happy learning.